Okay, hello everyone. We're gonna do our chapter 5, Pupil's book, Fractions, Word Problems, right? Why do we need to know different word problems? Well, this is, for example, like this guy, he's like really thinking, okay, how do I separate something like some volume, for example? He has a shelf, right? And for example, how do we separate shelf, right? He is really curious. He doesn't know what to do. Let's check it. So the big idea of the whole chapter is to understand how to use models and model drawing to solve word problems, right? Word problems, they could be confusing for students whose first language is not English, right? So let's check the first one. First lessons, how to solve word problems. Let's read this one, right? Sheena poured the first problem. Sheena poured 6 liters of water equally into 4 bottles. How much water was there in each bottle? You draw a model, and the whole model is 6 liters and 4 bottles. This is how you use model drawing to solve division, right? So you divide your unit bar into 4 parts, right? Pretty straightforward. 6 divided by 4. 6 divided by 4, I remind, is the same thing as a fraction, 6 over 4, right? So this is how they find this answer. Or if you make it as a division, right? 2 will be as a remainder, divide by 4. Okay? So 2 and 4 you can simplify, and then it's gonna be 1 and 1 over 2 liters of water in each bottle. Very easy to do. Let's check the next one. Right, Christina had 4 over 5 kilogram of diced potato. She used 1 over 2, half of it, to fill some curry puffs. Like all of these words that you will see, they can be unfamiliar for you. Something like what is this thing? Like, I don't know. Like this girl thinks, I don't know what is this. It doesn't matter. Doesn't matter what they tell you. Another confusing part, really confusing part for you is that they will give you a fraction and the mass, right? So they show you the mass that it's not going to be a whole number. It's not going to be 1 kilogram, 10 kilograms, 5 kilograms, right? It's going to be a fraction. So that's what confuses many people. They start to draw a model and say, okay, so if I have like 4 over 5 kilogram, then I need to divide it into like 5 parts. No, this is not what you do. You don't do like this. This can be 4 over 5 kilogram. This can be 1 kilogram. This can be 5 kilogram. This can be 10 kilogram. But they want to confuse you, so they give you a fraction, right? And they want you to not confuse you, but teach you how to calculate it. So whatever this number it is, this is a mass. And these numbers are the fractions. 1 over 2, 1 over 2, you have 2 halves, right? So starting from here, and in every problem that you will face, like you will see this kind of things. Maybe it will not be kilograms here, maybe like it will be meters or something. Don't confuse between the things that they show as a total and between the actual fraction part of the unit, right? Pretty straightforward. If you want to find this half, if you want to find a fraction of something, the fraction of something, the part of something, right? The operation that you do is multiplication. Multiplication, right? So we multiply 1 over 2. Okay, I don't need to write it down. They do it here. 1 over 2 times 4 over 5, right? And the answer is 2 over 5 kilogram. Now again, many students, they confuse. They think, why do I need to multiply this thing? So again, 1 over 2 times 4 over 5 is the same thing as 1 over 2 times 4 divided by 5 is the same thing as 1 over 2 divided by 5 times 4. Divide by 5 times 4. You can change these operations, right? It's the same thing if you can bring this 4 to the numerator. 1 times 4 divided by 5. Alright, there will be many problems again. We're gonna look through this. But always you do multiplication. Multiplication. When you need to find a part of something, you do multiplication. Okay, let's keep going. Alright, next page. So Katie used 1 and 3 over 8 kilogram of flour to make muffins. She used 1 kilogram less flour than Diana. How much flour did Diana use? Right? So this is what you do. You draw your model for Katie, and you know how much is this. 1 and 3 over 8, right? And they tell you she used 1 kilogram less than Diana. This is another girl. She's using more. How much more? This is how much more. 1 over 4 kilogram. So what do you need to do? Take a second and think about it. Yeah? What do you need to do? Very simple, right? Have this, you have this. How much is this? You sum up. It's an addition problem. 1 over 4. So again, the first step is addition, right? Your whole numbers first. Do it step by step, not to lose numbers, right? It's gonna be 2, 3 over 8 plus 1 over 4. Check your denominators. Different, right? Bring them to common. It's gonna be 2, 3 over 8 plus 2 over 8, right? Denominators are the same. Numerator, 3 plus 2 is 5. 2 and 5 over 8. This is your answer. 2 and 5 over 8. Right? Let's check the next problem. 2b. Regan obtained 1.5 cups of juice from a coconut. How many cups of juice can Regan obtain from 6 such coconuts? Right? Also, very simple. Here are your units. Each unit represents a coconut and like how much juice you can get from a coconut. One coconut gives you 1.5 cups, right? This is the multiplication. You have one coconut gives you this, one unit gives you 1.5 cups, right? 6 units gives you 6 times 1 and 1.5. 6 times this fraction, right? All you need to do is to calculate it. Now again, I remind you of the easy way to do it, right? The long way to do will be to take this whole number and transform it into improper fraction. Now, what is easy to do, right, is you take this fraction and you break it into 2 halves. You make it a sum of 1 plus half in the parentheses, 6 times, right? 6 times 1 is 6 plus, this is this plus, right? 6 times 1 over 2, right? That's going to be 3. 6 plus 3, 9. That's your answer. 9 cups of juice from 6 such coconuts. Now, as you can see again in every problem, after they have the actual answer, right? After they have, sorry, this should be 2, 5, or 8. After they have an actual answer everywhere, 9, right? They make a sentence. So this is important to make a sentence. Why? Because they want you to process the answer. Sometimes you get some kind of number, and when you put it in the sentence and you read it as a sentence, it doesn't make sense at all, right? It's like, I don't know, Regan can obtain 5,000 cups of juice from 6 coconuts. You think about like, how can she make so much juice from 6 coconuts, right? Something's wrong with math. All right, this is a silly example, but it basically gives you the idea of why it is important to write the sentence and actually process it, right? To understand. All right, let's keep going. Okay, Next problem. Here we learn, right? Learning part. So Sean cut a pole into 3 shorter poles. The first pole was 1.5 meter long, and the second pole was 1 10 meter long. The third pole was as long as the first pole and the second pole together, right? First question, how long was the third pole, right? Second question, how long was the original pole? But first, so this is what they do. Right, you can read through this thing, but basically look at this model, right? One unit bar represents first pole with the length of 1.5 meter long. Another one represents the second pole. So they ask you how much is together. This is your addition. You add up two fractions and you get your answer, and this is your answer as a sentence. The third pole was 2 and 3/10 meters long, right? So they ask you how long was the original pole, and even this unit bar actually looks like a pole, right? He cut it. That was the first one. That was the second one. This is the one that we found, the third pole, right? So this is what it is. All together, how much? How much? They ask you. You do the same addition. This is the answer, right? This is interesting step. How can I check my answer? I can work backwards to check my answer. Work backwards is you take your pole with this thing. Imagine that you have a pole with this length, right? And you cut it into 3 parts. And the first part is the one given here. The second part is one given here. So 1/5 and not meters. And another one is 1 and 1/10 meters. You have these 2 parts. How much is the third part? You're gonna have this number. Okay, easy. All right. Again, learning problem, right? We're learning. There were 217 children and 84 adults in the library. 5/7 of the children in the library were boys. Questions. How many boys were excuse me, how many boys were there in the library? How many fewer girls were there than the boys? Right? If you think about the questions, this is also kind of an important note, right? If you think about the questions are only about the children. So this information, like 84 adults, we don't care. Like, who cares? It's absolutely useless information. What we care about is the amount of children. This is what we do. We draw our unit bar, right? And we look at now. 5/7 of the children in the library were boys. Instantly we're thinking, how many parts gonna be? 7. 1, 2, 3, 4, 5, 6, 7. We divide it into 7 units, right? 5/7. So our 5 units here, right? Were boys. So we don't know how much. We need to calculate. If 7 units were 217, right? 1 unit. We need to know 1 unit. We divide. This is our 1 unit. 31, right? How much was 5 units? 5 units, 155. And this is our answer as a sentence. There were 155 boys in the library. Okay, we got it. Now our next question. How many fewer girls were than the boys? Right? We need to calculate our girls. Right? We can calculate them like that. So 5 units. We compare our 5 units and 2 units of girls. Right? What is the difference? The difference is these 3 units. 3 units. So we multiply 3 units. 1 unit is 31 and we got 93. This is the difference. And this is the answer. There were 93 fewer girls than boys. Now, this is the way, as I said, model drawing is what when they teach you in Singaporean system in school. The method too, right? Everyone's gonna calculate this thing. Like in the real life, you're gonna work with fractions, right? So you have your total number, you have the fraction, the part of the whole. 5/7, 5 parts of 7 parts of 217 kids are boys. This is your answer. 155 boys, right? They ask you, what is the difference? So you can know that your difference from the model that is 3 units, right? So this is your 3 units. 3 parts out of 7 times 217, 93 fewer, right? Well, for example, what you can do is like, to double check yourself. 5 sevens are boys. How many girls? 2 sevens. Girls, right? 2 sevens. 2 sevens. Again, from here we know 2 units. 2 units are girls, 1 unit is 31. So 2 units is 62, right? How much is 155 minus 62? This much. 93 fewer girls than boys. Alright. Okay, now we learned, we need to try. Right? I hope nobody had problems with that. So pause the video. Oh, I hope you should have done this by now. Try to solve it yourself. Alright, and now let's work all together. So, same problem. There were 312 people in a theater. 120 were children, and the rest were adults. 1/3 of the adults were men. Question number 1, how many adults were there in the theater? Question number 2, how many men were there in the theater, right? Okay, very simple. You draw they already did everything for you, right? You just need to learn how to copy it. You draw a unit bar, and that represents the total people in the theater. You divide it in 2 parts, right? One part shows you how many children were there. Another part we need to find, because they tell us the rest were adults. So we are asking ourselves, how many adults, right? So what is this thing? 312 minus 120 is equal 192, right? 192. Again, as a sentence, the answer, there were 192 adults in the theater. Now they tell you, they ask you second question, how many men were there in the theater, right? How many men? Okay, we know that 192 adults are here. We draw again our unit bar, right? This is 192. Now they tell us on this over here that only 1/3 of the adults were men. So we show that we have our 3 units. 1/3 were men. 1/3. These are men. How much? Right? 3 units is 192. 1 unit, right, is 192 times 1/3. How much is that? Do your math. 64. Again, write the answer as a sentence. There were 64 men in the theater. Okay. Learning problem number 3. Maurice had 4/5 kilogram of shredded chicken and 7/10 kilogram of smoked duck. He used 1/4 of the shredded chicken to make a salad. How much shredded chicken did Maurice have left? Okay, so very, very straightforward, right? Again, this thing, like what they tell you about smoked duck 7/10, like we don't care. They ask you question, specific question. How much shredded chicken did Maurice have left? He had this amount. He used this fraction. Again, the difference between the amount in kilograms and fraction, right? He had, like we could say whatever, like he could 10 kilogram, but he had he used 1/4, right? So he had left 3/4 left, right? If he used 1/4, there's gonna be 2.5 kilogram. In our case, it's not, let's say, 10 kilogram. In our case, it's this one, 4/5. 4/5. And if you want to know the used part, we multiply the fraction. Multiplication. They calculated 1/5 kilogram. That's the answer. Maurice used 1 over 5 kilogram of shredded chicken, right? Now they're asking us how much is left. Right? How much is left? He used this, he got this. Simple subtraction, right? He had 4 over 5 kilogram, he used 1/5 kilogram. This is how much left. Maurice had 3 over 5 kilogram of shredded chicken left. Okay, method number 2. By this one, they show you whole, everything that he has. Whole, shredded chicken, right? Everything that he had, they show as one whole. And now he used a part of it. Which part? 1/4. 1/4, a quarter. A quarter was used. He used a quarter of shredded chicken. How much left? 3/4, right? He had 1 whole. He used a quarter, 3/4 left. This is the answer. Maurice had 3/4 of the shredded chicken left. Now they ask you how much is that in kilograms. Now, 3/4, right? 3/4 of 4 over 5 kilogram. This is the mass of the chicken left. Mass of the shredded chicken left. Here is your answer. Okay, now we learned that. Again, all this problem, the whole problem. I'm gonna erase this, not to confuse you. All this problem is dedicated only to one thing, so you don't confuse the fraction that shows the whole mass and the part of it, right? If you draw your units, again, he had like, I don't know, the whole one will represent, it can be 10 kilogram, it can be 100 kilogram, it can be whatever whole number, and it's gonna be easier, right? But they give you some fraction, 4/5 kilogram, which is, if you think about it, 800 gram, right? And he used this 1/4. This is why the whole problem is given to you. So you don't confuse the fraction that shows the whole mass and the fraction that is actually a part, the fraction of the total. Now let's focus on this problem, right? I'm gonna erase this thing. Okay, let's focus on this problem. Try. So Priya, an Indian girl, had a piece of string 5 over 8 meter long. She used 3/5 of this piece of string to make a bow. What was the length of the string left? Give your answer in its simplest form. Absolutely identical thing. And because it starts with 1 here, it's going to be the method 2 that they propose, right? This 1, again, if it's easier for you to think, you just use your units, right? Draw a unit bar, and the total length will be 5 over 8 meters, right? Now, this is what she used. She used 3 parts out of 5. So you draw your 5 units, and she used 3 of them. Used, they're gone. You can draw them again if you want, right? 3 units. Used, right? This is what is left. 2 units, these 2 units. Right? And this is what we do. 1 as a whole minus 3 of 5 parts gone, 3 over 5, right? 2 over 5 left, 2 over 5 left. 2 over 5 parts, 2 parts out of 5, 2 units out of 5. How much is that out of 5, 8 meters? This is what you need to calculate. Right, 2 times 5, it's going to be 10. 5 times 8, it's going to be 40. Right? You remove this thing. So it's going to be 1 over 4. The length of the string left was 1 over 4 meters. Or without a multiplication, right? You just simplify this thing. 5 and 5 kill each other. 2 and 4. 1 and 4. 1 over 4. This is how we do it. All right. Okay, these next problems are a little bit harder because you need to think of remainder, right? Learning problem. Arif received some money for a weekend job. Okay, man got money. He saved 1/4 of the money. Okay, he spent 4/9 of the remainder on a DVD and spent the rest on a t-shirt. Question 1. What fraction of his money was spent on the DVD? Question B. What fraction of his money was spent on the t-shirt? Alright, this is what you do, right? You get your first unit bar. This is his total money. They tell you, this is some money of his weekend job, right? This is what they tell you. He saved 1/4 of the money. And this is what they draw. This is saved. The left one is called the remainder, right? It's these 3 units. Now what is happening with this remainder is they're showing by the arrow that, okay, we draw these units again. This is saved, all right? Now we have to split the rest. We have to split the remainder. 4/9, right? So what do? We divide this thing into 9 parts, 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units, right? They tell us he spent 4/9 on a DVD. 4/9 are spent on the DVD, right? When we will split our units like this, we will see that, so this is a quarter. We will see that, or 1/4, right? I call it quarter. So 1/4, right, is actually consists now of these 3 small, sorry, so ugly, but you get the point, right? These 3 smaller units. 3 smaller units. And we can see now how many units, right? How many units, how many parts spent on each thing. 3 these small units. So the whole fraction has become not 9 but 12, right? The total number of parts in one whole is 12. 4/12 were spent on the DVD. On the t-shirt, this is the rest. 5/12. 4/12, it can be simplified and it's going to be 1/3. And write your answer as a sentence. Arif spent 1/3 of his money on the DVD, right? Arif spent 5/12 of his money on the t-shirt. Everything becomes very clear from the unit bar. Okay, now model is drawn. How about the fraction? How can we do it with the fraction? Simple, right? This is second method. You have 1 as a whole. 1/4 of the money is saved. This is saved. This is the remainder. And this is what they write. 3/4 of the money was left after he saved 1/4 of it, right? The remainder, now, this is the remainder, right? 4/9 was spent on DVD. The part of the remained of the left money, right? We calculate this, this is what we get. Arif spent 1/3 of his money on the DVD. And same thing is happening here, right? So we have our fraction of money that he had minus the money that he spent on DVD, the fraction of money, right? And this is, we calculate, we do the math, bring them to common denominator, and we find the fraction, 5 units, 5/12. And this is the same that we have here. 5/12 units spent on the t-shirts, right? 1/3 of his money spent on DVD. Yes, this is 4 units. 4/12 is 1/3. 1/3 of his money spent on DVD. 4 units out of 12 units spent on DVD. And saved 3 units. 3/12. 3 units out of 12 units 1/4. That's it. Okay, now we learned. Let's try. Pause the video, do the thing, and let's now do it again. Right? Do this problem together. Okay. So Anne had 288 tickets for to sell for charity. She sold 2/9 of the tickets to her family, 1/3 of them to her friends. Right? Very easy. How many tickets did Anne sell to both her family and friends? How many tickets were there left? Right. So this is your model. They kindly draw it for you. So 288 is your total. Right. Now think about it. 2/9 of the family. This is what they draw. Family. 2/9. The total amount of units here is 9 units. Right. 1/3 of them to her friends. Right? This is her friends. 3 units. 3 units out of 9 is 1/3. Friends. Sorry. Friends. Okay? These 3 units are her friends. And this is left. This is it. Okay? So they ask you a question. How many tickets did Anne sell to both her family and friends? Family and friends. 9 units is 288 total, right? So how much is 1 unit? 1 unit is 288 times, we want to know the part of it. 1/9. How much is that? 32, right? 32. Okay, so both family and her friends. This is both family and her friends. 5 units. 5 units. 5 units times 32. How much? 160. Right? This is your answer. Anne sold 160 tickets to both her family and friends. All right. Now we know our 1 unit. 1 unit is 32. Right? How much? They're asking us the next question. How many tickets were there left? All right? This is left. Left. This is left. 4 units. 4 units times 32. How much is that? Okay, 128, right? 128 tickets left. These are your answers. This is how they should look like in the end.